Hello, let's see the next part from design of steel connections, that is design stresses in fillet welds. In the last lecture we have studied 9 design specifications of fillet welds, and after that this is some important part: design stresses in fillet welds. First one, shop welds. Design stress of a fillet weld, denoted by FWD, shall be based on throat area, and it is given by FWD is equal to FWN upon gamma EMW. Okay, fillet weld or net fillet weld upon gamma EMW is equal to FU upon root 3 upon gamma EMW. Okay, and it will becomes FU upon root 3 gamma EMW. Okay, because we don't know the value of FWN, and for that we convert FWN in the form of FU, and it becomes FU upon root 3, and the formula of FWD is becomes FU upon root 3 gamma MW, where value of FU and gamma EMW is known. What is FU here? FU is smaller of ultimate stress of the weld or of the parent metal. Okay, जो नवीन वेल्ड केलेला मेटल असेल किंवा पॅरेंट मेटल म्हणजे जो सुरुवातीचा मेटल जो असेल, जो पार्ट असेल जो की जोडायचा होता, त्याचा FU. गॅमा MW इज partial safety factor that we have already known, and its value is 1.25 for shop welds. It is very important. Partial safety factor for shop welds is 1.25, and for site welds it is 1.5. okay, because in the numerical you have to given during a shop welding or during a site weld, and then whole statement is given, but it is clearly mentioned that shop weld and site weld in the statement, and for that it is very important to take the value of gamma MW 1.25 for shop welds, and if there is site weld mentioned in the numerical, for that you have to take gamma MW 1.5. okay, then site welds, in this case gamma MW is taken as 1.5. design stress for site weld becomes, okay, FWD is equal to FU upon root 3 gamma MW, where gamma MW is 1.5. just value of gamma MW different in first and second case. In first case gamma MW is 1.25, and in second case gamma MW is 1.5. that is a major difference between shop weld and site weld, and these values you have to remember for the design of fillet welds. okay, then design strength of fillet weld of length L is given PDW, design strength of fillet weld. okay, PDW indicates design strength of fillet weld. okay, PDW is equal to FWD into L into TD. okay, now we have already calculated the value of FWD, and L and TT will be mentioned in the statement. FW will not directly given, that FWD we have to calculate from the shop weld or site weld mentioned in the statement. Okay, that we have seen in the previous slide. This, from this we have to calculate FWD, and then PDW is calculated from this formula. This formula you have to remember. PDW is equal to FWD into L into TT, where L is effective length of weld, TT throat thickness of weld, and FU is 410 Newton per mm square. Gamma MW 1.25 for shop weld and 1.5 for site weld. Then just calculate FWD for standard case, that is for taking FU 410, gamma MW 1.25, that is for shop weld. We can calculate a standard value. Okay, FWD 189.37 Newton per mm square. It will be a we can say standard value when we take FU 410 Newton per mm square and gamma MW 1.25, that is for shop weld. It will become 189.37 Newton per mm square. Then design strength of shop weld for a length of 1 mm. Then for 1 mm length, it will become the PDW becomes FWD into L. We are taking here 1 mm, and into TT. Okay, throat thickness, and that is, we know that we are taking 0.7 s. Okay, then it will becomes 132.56 s, where s is size of the weld in mm, and that will be given in the statement. Okay, then analysis and design of fillet welds. Just remember these some standard points for before going to design a fillet welds. Okay, this is a required information for going to design a fillet welds before going to design any type of weld. So just read and remember these points. A fillet weld may be subjected to direct bending and shear stresses, but the shear controls the design, since the fillet always fails in shear at an angle of about 45 degrees through the throat. Okay, first assume the size S of the weld based on the thickness of member to be connected. Then calculate the strength of fillet weld per mm using the formula PQ is equal to FWD into L into TT, where L is 1 mm. Then estimate the pull, or pull means we can also say it is tension, or thrust means compression, to be transmitted by the connections. Then calculate effective length of the weld using L is equal to PDW upon FWD into TT, or PDW upon PQ. Okay, this is a just previous formula, that is PDW is equal to L into FWD into TT. That is the only rearrangement is done to calculate L. adjust this length either by longitudinal fillet weld or as transverse fillet welds perpendicular to the direction of load. Transverse means along with longitudinal fillet welds. Okay. Then if only a longitudinal fillet weld is provided, check that the length of each longitudinal fillet weld is greater than the perpendicular distance between them. And then finally provide end returns of length is equal to 2s at each end of the longitudinal fillet weld. Then final point is to calculate end returns of the length, and the end returns calculated by using the formula is equal to 2s, that is 2 into size of weld at each end of longitudinal fillet weld. Okay, this is all theory information we have required for calculation of the or for design of fillet welds. In the next lecture we will try to design some fillet weld or welded calculation problems. Okay, just remember all the things, note down it all these things in your notebook. All the formulas we have studied, just note down all formulas. There are only few formulas are there, and that formulas we will use for the design of these welded connections. Okay, then in the next lecture we will see actual design calculations or design of welded connections. So thank you.